Guys, this is one of those labs where you're going to want to probably print it off. I mean, yeah, you could do it on your computer, but it's a lot easier to handwrite and then type up later. Anyway, I'm trying to film this as best I can with my tripod. We're going to have a lot of different parts to this video that are all going to be linked together. So let's start off by just writing down that this is, put your name on here, okay, Mr. Roboto, and this is lab number 19. Though, you know what? I don't think it's going to count for any lab minutes technically, but whatever. Okay, so there's a pre-lab section up here. It has to do with the notes that I went through on porosity and permeability, and you can just answer these questions. Porosity, permeability definition. Round particles have a blank porosity and flat particles have a blank porosity, so like low and high kind of thing. Tightly packed low or high, or loosely packed low or high. What effect does size have in porosity? That was answered in the video as well. And then you have some hypotheses down here. So it says which material will have the highest porosity, the lowest porosity, the highest permeability, and the lowest permeability. Now I have 3 different size sediments, and I'm going to show them to you. This one right here, coming into view now, this is the large pebbles. Okay? So you can kind of take a look at that, large pebbles, what that looks like. This one right here, coming up, these are small pebbles, okay, smaller pebbles. And then finally, we have coarse sand coming into view now, coarse sand, okay. So you guys decide on that. I'll let you take your pick. Hypotheses are never right or wrong, it's just a guess. Now, down below here is where we're actually going to be collecting some data. Okay, I'm learning quickly that this is going to be a super difficult lab to do on a video, but the first thing we're doing for porosity is we need to figure out the volume of sediment inside of this tube. So the first thing we're going to have to measure, as it says on the bottom of your lab, is to measure the diameter of the tube in centimeters. So I'm going to do that right here, and I'm going to just tell you the number because it would be really hard for you to figure this out. The diameter of this tube is 3.5 centimeters. 3.5 centimeters. And that's true for all 3 of them. All 3 of these tubes are exactly the same. Okay? So 3.5 centimeters. Now, second thing we're going to have to do is measure how much sediment is in this tube vertically. I'm going to do that with my ruler again. I'm measuring from the bottom here, so down at the bottom, as you guys can see, all the way to the top of the sediment up there. And if you look closely, the top of the sediment is right around 34 centimeters. So that's for the large pebbles. The height is 34 centimeters. I did the same thing for the other 2. And the small pebbles is 34 centimeters. And the coarse sand is 31 centimeters. Okay? We have our measurements. We're going to calculate the total volume. And if you look at number 3 here, it says that the volume is equal to pi r squared times h, that being the height. Okay, so down below here, I did a little calculation for the first one for you. So pi times the radius, that's half of the diameter, 1.75, squared, times the height, which is 34 for the large pebbles, and what I get is 9.62, which is this inside part, inside the parentheses, times 34, and then I multiply those 2 numbers together, and I get 327.08 centimeters cubed for the volume, 327.08. That's centimeters cubed, but that's actually the same thing as milliliters, so we don't have to label it here. Now, I'm going to let you guys do this one and this one on your own. If you notice, these 2 numbers are the same as these 2 numbers, so guess what this volume is going to be. This one you're just going to have to multiply by 31 instead of by 34. Okay, so that's the only difference there. Now, after you've calculated the total volume, I'm going to show you the pore space. Continuing in the procedure, it says for step number 4, fill a beaker up to 200 milliliters of water. So I'm going to do that now. I dyed the water green so you'll be able to see it a little bit easier on your screen. I'm filling this up to exactly 200 milliliters of water, and you guys can see that's filled up to 200 mils of water. Okay? And then it says to slowly and carefully pour the water into the tube until it reaches the top of the sediment, and then measure how much you've poured in. So I have my tube here. I'm going to pour this in. Now, one key thing, if you were doing this yourself, you have to make sure that that little valve at the bottom is pinched off, because if you pour it in there and it just drains out the bottom, that would be a waste of your time. So I'm going to slowly and carefully pour this in until it reaches the top of the sediment. And you'll notice how it just trickles its way through all the sediment. I'll try to keep that on the screen as I'm pouring it in there. The really, really critical thing about pouring the water in here is making sure that you stop when it gets to the top of the sediment. And I'm getting there. Pretty close now. It's percolating through all the little pore spaces in between there. And by pouring water in here, we're filling up all those air gaps until it reaches the very top, and I am just about there. Okay? So notice that the water has filled in all the pore spaces in the entire container, and essentially how much water I poured in is how much air there was in there, and how much air there was in there is the pore space. So if I look on here, the container is now filled up to a level of exactly 75 milliliters. Now, is that the pore space? No. That's how much water I poured in. Now, how much did I have originally? I had 200 milliliters. So you have to do the math. What's 200 take away 75? And the answer is 125. So I poured 125 milliliters into the container here, which means the pore space is 125 milliliters for the large pebbles. We did the same exact procedure for the small pebbles. As you can see, the green water is filled all the way to the surface of the pebbles, and the amount of water I have left in the container is, again, interestingly enough, 75 milliliters. Okay, one more round again. I did it with the coarse sand this time. As you can see, it's filled right to the brim, and if you look at the amount of water that's remaining, I measured it pretty accurately. The level of water that remains is around 80 milliliters this time. Step. We have to calculate the porosity given the pore space that we obtained in our lab. And as you can see, I wrote down the pore space for all three of them. So if you didn't figure it out on the last two, small pebbles and coarse sand, the pore space for the large pebbles and the small pebbles happens to be the exact same thing. For the coarse sand, it's 120 milliliters. Now, to calculate porosity, it's a simple calculation. It's just division. So we have the pore space, I'm doing the large pebbles here, pore space, 125, divided by the total volume, 327.08, and then you divide that and multiply by 100, and you're going to get a percentage. I'm rounding it to the tenths place, and you guys can do the exact same thing. So the percent porosity for the large pebbles is 38.2%. Okay? And you guys can do the same thing for these last two. I'll let you fill in the blanks here. Guys, on to part 2 on the next page, permeability. Permeability is, again, the ability of water to pass through the sediment. We're going to use the exact same tubes again, and we're going to start with 200 milliliters of water. And if you read the procedure, it says to pour all 200 milliliters into the tube with the valve closed. So the valve is closed. I'm pouring all 200 milliliters in here. And good, we're up to 200. Now, it says, as you can see, the water is above the sediment level, and that's okay. We're just timing how long it takes the water to drain out the bottom down here. Okay? Now, this is a little bit tricky as a one-man show, but I have a stopwatch here. Okay, and I'm going to take the valve off, and as soon as I take the valve off, I'm going to start my stopwatch, and we're going to time how long it takes for this water to drain out of the tube. Okay, so here we go. 1, 2, 3. You can hear it draining out. see it draining out. Okay? And once it's all drained out, I'm going to stop my stopwatch. Good. Okay. And if you look at the time, it's 19 seconds. And you're going to record that for the time for water to pass through. Alright, I'm going to repeat this again with the small pebbles this time. So I'm pouring all 200 milliliters of water into the small pebbles. Okay. And you can see it's bubbling because all the air is getting forced out. Okay. And again, we're going to time the small pebbles. Again, tricky operation here. Set my stopwatch to 0. And I'm going to release the valve. Start the stopwatch at the same time. And here we go. If I can do this. Take the valve off first. And we're starting. And time is about there. It's still dripping a little bit, and we'll stop it now. Okay, that looked like it was about 27 seconds. So we'll write down 27 seconds for small pebbles. Okay, and we're going to do the final one, the coarse sand. Pouring again all 200 milliliters of water into the container. Alright, and again, you can see the bubbles. You see the percolation. The water is pushing the air out. The air is being forced up. And we're going to, again, time how long it takes for the coarse sand, for the water to travel through the coarse sand. And again, tricky operation here. We've got to reset our stopwatch. And we're going to start it as soon as I release and go. As you can tell, this is a little bit slower operation. The water is taking its sweet time getting through that coarse sand. Okay, and it's going to drip for a long time here. I'm going to let it drip, drip, drip for a while until it's completely gone. Still dripping. And we're about there now. Okay, 38 seconds for that last one. So again, write 38 seconds for time for water to pass through for coarse sand. As you can see, I recorded my data here. We have 19 seconds for the large pebbles, 27 seconds for the small pebbles, and 38 seconds for the coarse sand. Now, if you remember, the distance traveled is essentially how tall the sediment was, which we actually have from the previous page. If you remember back to page 1, we had some heights here that we measured, 34, 34, and 31, and you can just copy them down here. So 34 centimeters, 34 centimeters, and 31. Now, a simple calculation here of permeability. Permeability, if you want to calculate it, is the distance traveled over time. It's a speed calculation. So what you would do for this first one, I'll let you do the other two, it's 34 centimeters divided by the time, which is 19 seconds. And if you use your calculator, you can round it to the tenths place, that's fine. You're going to get 1.8 centimeters per second. So that's the permeability rate for the large pebbles. And I'll let you do these last two. Okay? Okay guys, last thing, just to kind of wrap up this lab. We've done the calculations, we've done all the work for this lab, and the remaining part of the lab is just conclusion questions. So, what you're going to do when you're typing up this lab, you're going to go onto Google Drive, download this lab, and you're going to type all of your responses into the blanks that are in the lab. So the hypotheses, all the numbers you're going to put in here, you're just going to type them in. The numbers you put in the permeability spots. And then for your answers, just write your responses underneath of the question. Don't delete anything, don't erase anything. Just type up your responses in this area underneath here, okay? And you're going to do that for all of the conclusion questions as well as the questions on the last page. Just type up your responses. And again, it'll just expand if you need to write more. I like complete sentences when you're writing the answers to these questions. So make sure you're, completely explaining your answers. Down below, there's a diagram, and you're going to answer these questions as well. The last question is a multiple choice question. If you want to just, highlight the one that you like, or if you want to just write underneath of it whatever letter you chose, that's cool, whatever. Okay. And so that is the end of this lab. And then you're going to submit your lab online, and this lab will be due on Friday. Okay. And if you have any questions, just send me an email. Thanks.